Okay. Hello and welcome to our webinar, Analyze This, CloudBees Jenkins Cluster Operations and Analytics. My name is Alyssa Tong and I'm with CloudBees. Today's webinar is presented by CloudBees. CloudBees is the enterprise Jenkins expert and the leading provider of Jenkins solutions for continuous integration and continuous delivery. Next slide, please. So our presenters for today are Ryan Campbell and Cyril Leclerc. Ryan is a Jenkins engineer at CloudBees, and Cyril is Director of Product Management. In this webinar, Ryan and Cyril will show you how organizations are using Jenkins to onboard teams. They will walk you through how CloudBees Jenkins Operations Center is the tool that helps organizations run their continuous integration infrastructure at scale so that they can remain competitive in the market. So at this point, I will hand it over to Cyril.
Thank you very much, Alyssa. Hello, everybody. Thank you for joining this webinar. The agenda for this 60-minute presentation will be first the problem statement, the reason why we will present these features of Jenkins Operations Center by CloudBees. Then we will cover the reference architectures that we recommend people to implement when they use Jenkins in their organization. Then we will cover CloudBees Analytics, a new monitoring feature part of Jenkins Operations Center. Then cluster operations to help you to manage your Jenkins infrastructure. It's also a new feature in Jenkins Operations Center. And then we will conclude our presentation. So first, the problem statement. We could say the big topic, high-level topic, is how to onboard more and more teams on a Jenkins continuous delivery platform. And from a technical standpoint, how to scale Jenkins in an organization, how to make it possible for Jenkins to support these new teams all the time. If we look at the usage of Jenkins in organizations, typically people start with something like 5 projects. We start a Jenkins master open source on a computer, on a development computer, a desktop. We have 0 slave, and then progressively we increase. We have 25 projects, something like 5 slaves, then it can go to 100 projects, 25 slaves. We have more and more projects under maintenance. In addition to active projects, we can go to 300 projects, 50 slaves, and we also see organizations with things like 600 projects, 200 slaves, and so on. So Jenkins can ramp up very quickly in organization, and it may be a big challenge to support this growth. How to support this growth? We know 2 approaches to scale software. The first approach is vertical scaling. We knew it with mainframes a while ago. And here the idea is to have a bigger and bigger and bigger single Jenkins instance, a kind of mega master. But there are many drawbacks with this approach. One drawback is that it is a single point of failure, and so we are very frightened, and the question is when will be the next failure, as all the team are stuck when this single master fails. Other challenges are that many different teams may have different expectations on Jenkins infrastructure. Some people want very recent versions of plugins. Others prefers to have stable versions. Some people want plugins that are incompatible one with the other. So this scalability approach is limited because the size of boxes is limited. It cannot scale at the infinite. And then collocating people can have several drawbacks. So there is another approach which we which we could name horizontal, but in fact what we see on the field is that it's more a viral approach where each project team is happy to install its own Jenkins master. So we see many Jenkins master in the organization. It's very nice because it shows that people like continuous integration. They like to test and build continuously their application. But the drawback is that it may become a mess. And there are things that we would like to solve with this kind of many master approach. Things we would like to solve, we would like to have. The first thing when we have many masters is that we have many slaves which are not working a lot, not building a lot. The usage ratio is low, and what we would like to do is to share the slaves between the masters, so that when one team don't use its slave, then it will share its slave, give its slave to another team. For example, some teams prefer to build during the day when some other teams need to build during the night or during the weekend. Things like this that make sharing slaves very valuable. Another feature that we want to have is related to security. We have to secure Jenkins infrastructure to enable authentication on it and also authorization. More and more companies have compliance rules, security rules, limit access to certain resources, and with continuous delivery on automated deployments. We have even different roles on the Jenkins platform for each project. Some people are allowed to deploy, some others only to build, and so on. And so here, instead of letting each team configuring its Jenkins infrastructure and maybe forgetting to enable security, this sometimes happens, we would like to have a shared security, a top-down approach for security where we combine flexibility for project team where they have their own master, maybe choose the version of the plugin they want, with this top-down this bottom-up flexibility with a top-down approach on the security for compliance. Another feature that we want also is to manage the masters globally. Sometimes we want to upgrade the plugins on all the masters. Let's say that there is a new version of the Git plugin that we want to use, and it's related to the Git binaries that we have installed on each box. And here we would like to globally perform maintenance operations. They can be install or upgrade plugins, maybe also upgrade Jenkins core, and we have to remember that it is important to very frequently update Jenkins core on the plugins to maintain an up-to-date version that is easy to manage. We may want to perform upgrades, as I said, to trigger restarts, to trigger backups of masters, or maybe also to execute Jenkins scripts, typically Groovy scripts for maintenance reasons. Then another key features that would be very valuable when we have to manage many Jenkins masters is monitoring the health of the Jenkins infrastructure, and discover if the platform slows down, if there is some wrong usage of the platform, somebody was misconfigured their job, things like this. So we would like to have a centralized dashboard of the Jenkins infrastructure with thresholds, alerts, not only at the system level like CPU, memory, but also Jenkins indicators. Do I have enough slaves? Do I have too many slaves? Do I have a starvation, a lock, something like this? So these were key features that we want to have when we federate many Jenkins masters. The solution proposed by CloudBees is called Jenkins Operations Center by CloudBees. This is an approach based on a Jenkins platform, where the Operations Center will be the federation layer node of your infrastructure. where you will be able to share slave. As you can see on this sample, my master nodes A, B, and C have a very limited number of dedicated slaves. Some of them even don't have dedicated slaves, and I maintain a shared pool of general purpose slaves on the Jenkins Operations Center. And when needed, Jenkins Operations Center will give the slave to the master and then take it back when it's no longer used. Another key feature will be related to security, and I will just configure security once on the Jenkins Operations Center. On all my masters will use this security, this authentication, and also the authorization, the roles, the group that I define at the Operations Center level. And for this, with Jenkins Operations Center, I will be able to reuse the Jenkins authentication and authorization plugins that I use on my master, because Jenkins Operations Center relies on Jenkins platform itself. So this was the second feature, centralized security, top-down security. Another key thing that we solved is the management, centralized management. Here we are able, from the Operations Center, to perform any maintenance operation on any master. We can schedule it, we can trigger it on demand. You can deploy, install, uninstall, disable plugins, upgrade Jenkins core, perform upgrades of all the plugins, restart, trigger backups, execute scripts, and so on. So you are able to manage all your Jenkins masters from one central point. And then another point is monitoring. Jenkins Operations Center will be the dashboard to monitor your Jenkins infrastructure, to monitor all your masters and all your slaves. So these are the features that are proposed with Jenkins Operations Center by CloudBees, the key feature of this product. Now I will cover the recommended reference architecture for Jenkins, the architecture that CloudBees recommends for Jenkins. We start with masters, so let's imagine my master A with some slaves. Then we will add high availability with clustering, and we will do it with Jenkins Enterprise by CloudBees, which is the enterprise version of the Jenkins Continuous Integration Server, where we support clustering with load balancer and so on for transparent failover. To scale, as we said, we recommend the scale-out approach, not the scale-up with one super big master, but the scale-out approach with many masters. Some organizations even like to give one master per team. This depends, but it's possible. Then we introduce Jenkins Operations Center. Jenkins Operations Center is also highly available with clustering on load balancing. Jenkins Operations Center will give you the shared pool of slaves to optimize the usage of your build servers. We define security at the Jenkins Operations Center level. So it's a standard Jenkins authentication plugin, maybe LDAP, maybe Microsoft Active Directory, or any other Jenkins authentication feature. We compose it with CloudBees role-based access control authorization, where you are able to define groups and roles. Groups can be provided by the LDAP server, by the authentication server, or can be defined at the Jenkins Operations Center level, or you can mix both. And roles also are defined in Jenkins Operations Center or on the masters and are kept in sync. Then we add a concept of update center. And if you want to control the version of the plugins that you deploy on the masters and not always use the latest version from the public update center jenkinsi.org, you can declare your own update center on your platform, where you can validate the version of the plugins that you make available, and you can also upload, register your own plugin. We know that many organizations develop their own plugin. And here it's a very elegant way to distribute these plugins and perform upgrades. You can also deploy Jenkins Core, the web application itself, also manage the deployment of the tool installers. It's also very valuable when you have firewalls in your organization. So this update center is typically defined at the Operations Center level. Then we bring single sign-on to this infrastructure so that it is very easy for users to navigate from one master to the other. Sometimes you have some masters with Linux dedicated to Linux, sometimes for embedded system and so on. So users, not only admins, but also developers have to jump from one master to the other. And it's what we bring with single sign-on. And the last thing that we recommend, and I would not say that it's a last thing, it's very important. It applies to both people using Jenkins by CloudBees on Jenkins open source, is to have a test environment. It is key to frequently upgrade your Jenkins core version, to upgrade your plugins. Recently, we have seen the introduction of workflow on Jenkins core, and to give access to the users to this feature, you need to upgrade, so be prepared. Have your testing environment where you can frequently test the recent version of the plugin, test new version of the core, test the upgrade of your operating system, of your build tool like Git binaries, subversion binaries, JVMs, and so on. And it's also an environment on which you will have your own update center. So this was the reference architecture for Jenkins recommended by CloudBees. We have webinars that go more in depth on this subject. Now we will cover several features during this webinar. We will focus on two sets of features. The first one will be CloudBees Analytics, your monitoring dashboard of your Jenkins infrastructure. And the second will be cluster operations, how to manage globally your infrastructure. So this was an overview of how to scale Jenkins in an organization, how to scale from a technical standpoint. There are also some organizational standpoints that we will not cover today. We will focus on two topics, CloudBees Analytics and cluster operation. And now I will give the microphone to my colleague, Ryan Campbell, to present you CloudBees Analytics.
Thanks, Cyril.
Please let me make you the presenter. You are the presenter.
All right. So as Cyril mentioned, I'm going to be covering CloudBees Analytics, which is a feature of Jenkins Operations Center. And just to refresh us, going back to Cyril's presentation, CloudBees Analytics gives you a global dashboard for your Jenkins cluster. So we'll get into what that is and how it works here. So, but first I want to talk a little bit about the drivers for why we created CloudBees Analytics. And a lot of this comes out of our own experience of running, a huge Jenkins cluster called Devitt Cloud. And we've got, hundreds or thousands of masters there. It is thousands. And those, what we found when trying to run that is that all of these masters running on different nodes, and there's different tools for monitoring them. And we really needed a consolidated monitoring platform to understand how they're working, if they aren't working, why not, and then how are they being used, so that we could improve our service to our customers. And I think this is a very common need actually in organizations where you have lots of Jenkins masters. You want to be able to answer some key questions, and that's what I've listed down here. Is these are some key questions that we felt like we needed to answer with CloudBees Analytics. So one is, what is the user experience? How fast are pages loading? How are builds working? Are users seeing errors? And then if there is a problem, why? What are the underlying causes of that problem? So for instance, why is Jenkins slow? Is it memory? Is it CPU or what? And then, but then not only from an operational standpoint do we want to answer some questions, but also from a more of a business standpoint. How is our business actually using Jenkins, and what kind of value are we getting from it? And then not only the value, but how is our usage of Jenkins growing, and what kind of capacity planning do we need to be doing in order to accommodate that growth? So before we get into the deeper parts of this, I want to talk a little bit about the pieces of CloudBees Analytics. So, you know, we've got the Jenkins Operations Center here in the middle, and on the left we've got a Jenkins master. And so you connect the Jenkins master to the Operations Center, and it immediately begins collecting data and submitting that data. You know, whenever various events happen within Jenkins, they're submitted to a Jenkins Operations Center. The second part here is a rich visualization interface. And this is basically some interactive graphs and charts that let you slice and dice this data in different ways. And then finally, there's a back-end compute and storage architecture that we'll talk about here in a moment. And that's actually pretty important. It doesn't seem like it, but as your usage grows, you want to be able to scale this out. So we've built the CloudBees Analytics with that in mind. All right, so a word on architecture here. So, you know, what is actually this made up of? And we want to lift up the curtain a little bit here and show you, I think there's some impressive tech underneath. And it's built on some open source foundations, especially the Elasticsearch search engine. And this is basically, what this is just a document database. And so, you know, as the data comes in from these various events, it's thrown into this Elasticsearch database, which automatically creates some indexes and other tools that are needed to create this visualization. And so Kibana is an open source tool for creating graphs and charts based upon Elasticsearch. And so we've integrated all this together and tied it up with a bow so that you can easily deploy this in a single Jenkins Operations Center. So there's no need to create you know, multiple nodes like you might with your own homegrown analytics solution, but rather all of this runs on the Jenkins Operations Center itself. However, we recognize that as your usage grows, you will need to add additional nodes to Elasticsearch. And this really speaks to the strength of Elasticsearch as a database, is that, you know, as you grow your Jenkins cluster, you'll have more data and more users, and so you'll need to add nodes. And this can be done in really an ad hoc manner, and Elasticsearch will take care of distributing the data as your cluster grows. All right, now that we've talked about the guts of this, let's really get into the functionality some and start our demo. Okay, so here we have a Jenkins Operations Center, and frankly, it looks a lot like a Jenkins itself, and that's no surprise. We reuse a lot of the same architecture as Cyril mentioned, but instead of having builds and slaves and jobs, what we have are Jenkins masters. And so that's what you can see here. We've got Ops01 and QA01. These are Jenkins masters. And let's just click on one of these and we can actually see that, yep, there's a Jenkins master doing some builds. And so that's what these are. These are called client masters. In fact, we can create a client master on Jenkins Operations Center in much the same way that we create a build job. So let's just call this master 01. We click new item here, calling it master 01. And we're going to call it a client master. And so that's a client master, that a Jenkins master that's connected to this Operations Center. So we do that. And to enable analytics, all we have to do is click enable. In fact, it's enabled by default. And so we save that, and then we would naturally give it the URL, for instance, of the Jenkins master. But instead of doing that, we're going to delete this guy because we've already got some Jenkins masters connected. So let's go back and take a look at these. Now that these are connected, they automatically start streaming their data in. And so there's two types of data that we currently present. One is build analytics and the other is performance analytics. So let's take a look at build analytics first. On this page, we can see the overall build analytics. And what this means is that every time a Jenkins master does a build, that data is submitted to the Operations Center. And so it shows up here as a count. So we're currently looking at a day ago for the last 24 hours, basically. And so in the last 24 hours, our Ops01 has done 261 builds, for example. But not only do we see the roll-up counts, but we also see the counts, over time. And so this is a histogram showing the builds for each master over time. And so we can kind of see the relative traffic on each one. And what's great about this interface is, well, first let's expand this out a little bit. What's great about this interface is that we can zoom in pretty easily on the data from a time perspective. So now we've gone into December 17th and 18th, and we can pretty much ad hoc just continue to drill down into this. But not only do we have the ability to drill down, but we can also zoom out and look at arbitrary time periods with just a few clicks of the button here. Besides the ability to navigate by time, we also can drill down by data. So let's zoom back out to, say, the last 24 hours, and we can look at, for instance, just the builds on Op01. And then we can kind of continue to drill down. And what we have, these other graphs here, they show us labels, and we'll talk about that in a moment. We have a general census of the source code control and the project type and the build and failure ratio. But I think what's really interesting is this notion of labels. So let's go back here and let's look at our builds by label. So as you may know, a label is a way in Jenkins to tie a job, a build, to a particular slave. And so you may decide that you have a build that needs to run on Linux, and it needs to run on a, a high-speed build machine. And so the way to do that is you basically attach it to the label of high-speed and Linux, such as this one right here. And so we can see over time basically the demand for these particular labels and what builds are popular. And so what's great about this is that this lets us understand the demand for these slave machines. So we can see how long those builds are running. And for instance, we had OS 10 for this time period, about half an hour. We had 281 minutes worth of builds completing. Now, how is that possible? Well, if you remember, there's potentially hundreds of slaves out there, so we would certainly expect multiple minutes of builds to complete in a given period. And so we can see, what is the usage like of our Jenkins, especially if we look and we back up here and look over, say, a 7-day period, we can see the peaks and valleys of our usage. And this is great when you need to schedule maintenance. You can see what is the natural usage of our Jenkins from a very objective standpoint without having to guess. And so the final graph over here is this average time in queue. And I think this is really the best graph for a team that is working on a budget, because what you see here is, this right here is a build is waiting in the queue. And what that means is that a developer is probably waiting on that build. And that's lost time on that from that developer's perspective. And so this is a great argument right here for budget. If you see, especially if you see this value increasing over time and you're seeing increasing queue times, then I think you've got a great argument and very objective data to bring to the budget discussion and to help you with your capacity planning. So just a little bit more on the navigation. If we wanted to see, if we were having some problems with failed builds, we could use this result navigator to narrow down which builds are failing and perhaps on which labels are we seeing those failures, and be able to understand if there's some correlation with time. And then as we drill down into that, let's say that we wanted to drill down into these failed builds here and get an idea for what's actually occurring. We actually see the raw data that backs that up. And so then we could use further analysis on these builds to understand why we see such a cluster of failed builds. So we have different ways of looking at this. We can do it by, we can see our overall failure ratio over time, and we would obviously like to see that diminishing and be able to understand any variations there. So that's really the build analytics piece. And but in addition to the build analytics, we also have performance analytics. So while build analytics is more about how my teams are using Jenkins and what's the business value, performance analytics is really targeted at the operations team. And I think if you're an operations team, I know a lot of them like to have large screens in their team room perhaps. And so we've added this full screen capability to give you a great radiator of information here. So if you're an ops team and you hear reports of Jenkins being slow, this screen right here can literally save you hours of time compared to having to log into the various machines and fire up different tools and establish an understanding of the data. It's all right here in one place. So if I was trying to understand why Jenkins was slow, I would one of the first things I would look at is the memory. And so if I saw sustained memory usage over time, well, that's an indication that we've got a resource problem there. We need to increase the memory. And I might look at how much garbage collection we're doing. I might look at the CPU usage. Or perhaps we have a lot of builds going on at once, and so I would see a spike in executor usage here. Another potential slowdown in Jenkins is if you have errant scripts, for instance. Often people will automate workflows by having one script download things from Jenkins, and they have a bug in their script, and that can really slow things down. So you would see that show up here. So besides the overall screen, we also have an HTTP performance screen. And this shows some similar graphs from what we saw before, but also provides some additional data, such as the average request time. And if you saw this peak or growing over time, then you would obviously be able to react to that. And then this 95th percentile slowest request is the 5% worst requests. How long are those taking? And obviously, if you saw spikes in that, then you would want to understand it better. And then finally, down at the bottom here, we see different status codes. If people are getting 500 errors, we would see those here, and likewise the 404 errors. So this is the performance analytics package. We also provide some analytics on the queue size. How is that growing over time? Offline node count. Actually, this really is a great bit of useful data here, that if you have a lot of nodes offline, that means that you have machines that aren't being used, and so you've got a utilization problem that you need to address. So that is the built-in analytics screens, both build and performance. But we also recognize that you'll want to create your own graphs and screens, and that the ones that we do out of the box, maybe they're not, don't include all the data. They certainly don't include all the data that we collect. So that's why we added this dashboard creator. And so this screen is really the raw Kibana interface that we provided built into Jenkins Operations Center. And so when you click on this, you get a little bit of information, but I'm going to show you just how simple it is to create one of these dashboards. And what we recommend that you do is take one of the existing dashboards, and I've got one already set up that's based upon the built-in dashboards. And so here we see the JVM and heap usage over time. So in this case, we've got it as a bar graph, but we want to be able to do it as a line graph. And so actually, let me show you real quick here. If we look at the panel types here, there's really a rich selection of different panel types that we can include. So histogram is what we use a lot of, but there's multiple spark lines, stats and tables and terms and so forth. So all of that is included here. But what we want to do is we want to just change this histogram from a bar graph into a line graph, because that's the way we'd like to see it. So we go to style here and we change it from bars to lines, and we're going to make that individual lines. That's how we'd like to see it. So we press save, and now we save the dashboard. And now we can go back into our Jenkins dashboard, now that we've created our custom dashboard. And we just click this plus button right here. And so we can create a custom view and then give it whatever name we want, say My Ops Dashboard. That's better. And so we call it a custom analytics view. And then once we do that, we click the add button here, and we select the dashboard that we created in the previous screen. And so perf overall, let's call it. And we press OK. And so now we have My Ops Dashboard with the custom graph that we created in the last screen. So that pretty much sums it up in terms of not only can you use the built-in dashboards that we created, but also arbitrarily create your own dashboards. So now I'm going to turn it back over to Cyril so that he can take us through the rest of the presentation.
Thank you, Ryan. Can you make me the presenter, please?
Yes. Just a moment, please.
Thank you. So I am sharing my desktop. Now we will cover cluster operations. So cluster operations are the solution to solve the question on how to perform upgrades on the Jenkins platform, on the masters, how to deploy new plugins and deploy and install plugin, deploy Jenkins, new versions of Jenkins core, perform upgrades, restarts, trigger backups, invoke scripts on the masters. The agenda for this part will be mostly based on demos. First, I will demo you how to update all the plugins on all the masters and perform a safe restart of the masters. Then I will illustrate a cluster operation with a more complex demo, which is how to deploy a new plugin on Jenkins masters. Then we will cover cluster operations features, our ref card of the cluster operations. So first, how to update plugins on all the masters on safely restart. I will do a demo. As my colleague Ryan presented you Jenkins Operations Center, I will go quickly on this. On this demo environment, I have 3 Jenkins masters, Jenkins A, Jenkins B, and Jenkins Test. So Jenkins A and Jenkins B are supposed to be my production masters, where I build my my production applications. And then Jenkins Test is my testing instance where I will test new versions of Jenkins, new versions of plugins, and so on. And here you can see these are Jenkins Enterprise by CloudBees Instant Masters, and this one is a testing version. So what I want to do is to update all the plugins. If I do it manually, what it would look like is that I would go on a master, I would go on Manage Jenkins. Here on Manage Plugin, I say, oh, updates are available. So I would go on updates available. Maybe I would trigger a check now to check new versions of the plugins. And then I would select the plugins I want to update and click on download now on installing after restart. So this would be the manual procedure to do it. I will show you how to do it with Jenkins Operations. Oops, this is the screen that I want. So here I will create a job that will be called update all plugins on all masters on safely restart. To create a job, as Ryan said, to create a client master, this is a very standard Jenkins style. New item, my operation, and then the type will be cluster operation. So instead of being freestyle project or Maven project, here this is a cluster operation. I already created one. Here I will show you how it works. Oh, I have to update it. First I will trigger the operation and then I will show you how this is implemented. So here I will trigger the operation. As you can see, this is a very standard look and feel of Jenkins job. And here you see the build history and you see the logs. So all this is very standard. While my Jenkins master are restarting, I will show you how to configure a cluster operation. Always the Jenkins job user interface with the same history of builds, the same capability to parameterize builds. I have build triggers so that I can schedule a cluster operation. Maybe I want to schedule upgrades of Jenkins master every Saturday night, things like this I could do. And then instead of having build steps such as Maven step or shell step, here I have operations. Operations, there are two types of operations. Here with add operation, I have masters operation on update centers operation. For this sample, which is update all plugins on all masters, I just need a master operation, so an operation on Jenkins master. When I do an operation on Jenkins masters, I will first select the masters that must be modified, must be invoked. My selector can be just take the operation center root, so it can look at all the masters of my Jenkins Operations Center. I can use a parameter, I can use a parent project, or I can use all the masters who are connected to the same update center. Once I have selected a group of masters, I can apply a filter, maybe a pass. So here, if I want to take all them, I would use a star pass, and otherwise it's a standard pass expression that I am familiar with in Jenkins. I could also just do it on the masters that are online or so on. For my sample, as I want to update all the masters, I don't need to put a filter. For the next sample, I will use one. Once I have selected my masters, on here I select all the Jenkins masters, I will define the operations themselves. There are steps. And I do several operations. I will first refresh the update center metadata. If you remember, I clicked manually on check now. Then I will call upgrade all plugins, and then I will call restart. So these are the three operations. I showed you how I would do it manually with the user interface. Here I will automate this sequence, and then I am done. Now I will look at the history of these jobs. And here you can see that on the history of the job, I have the standard console output. It was started by user admin, which is me. So I can apply the same security rules on cluster operations as I am used to apply security rules on any other type of job. And here you have seen that the clustered operation has been invoked on Jenkins A, on Jenkins B, and on Jenkins test. So the three masters have been invoked, have been involved by this operation. And here I can see the logs for each of them. Oops. Yeah, please ignore this. This is a demo effect. So then I am restarting my masters, and I can show you on Jenkins test. I think the master has restarted, so it's a bit slow because it has been restarted by this cluster operations. So this is restarted, and now you can see that I no longer have plugins updates available. And if I go on manage plugin, here my plugin has been upgraded. So this was a demo on how to perform updates of all the plugins on my Jenkins masters. To summarize this demo, cluster operations in Jenkins, they are standard Jenkins jobs. So it's new item as I'm used to do. Same naming style. On this type is not freestyle, is not Maven, but is cluster operation. On it supports the standard style of Jenkins definition, where I can have build triggers, I can have build parameters, and so on. What is different from the other type of jobs is the steps that I define. First, I create operations based on masters or based on update centers. For this demo, it was just masters. The next demo will also cover update centers. So here, only operations on masters. I select the masters. I have several criterions to select the masters. And then I select the steps that I apply on my masters. Here, refresh update center metadata, upgrade.all plugin, self-restart. So it is very simple to define this kind of cluster operation, and I may trigger it or I have audit on it and so on. Now I will show you a more complex demo, which is how to deploy a plugin on Jenkins Masters, and I will do it with a custom update center, so I will add a bit of complexity. The idea is that I want first to upload a plugin, so here this is a scenario where I develop my own plugin. It's not a plugin that is made available on jenkinsci.org, it's my own plugin. I could do a demo with plugins from jenkinsci.org. I will upload the plugin on my update center. Then I will go on one master. Here it will be master test, and I will refresh update center metadata to be sure that this new plugin, this new version of plugin is discovered by my master. And then I will trigger install the plugin, which is install or upgrade. So now let's do the demo. For the demo, I prepared a demo job on Jenkins test. So if you remember, this is Jenkins test, and I have the test job. The test job is a freestyle job. When we look at the configuration of this freestyle job, one step is a build step that is my plugin. Here, this plugin is Say Hello World version 1.3. So this is the current version, and I will want to deploy the version 1.4 of this custom plugin. I prepared for this webinar a sample project, sample Hello World plugin. So here I updated it. So on my computer, I have version 1.4. And here the display name will also be 1.4. Please believe me. Yeah, here version 1.4. So I will want to upload this plugin and then deploy it. Let's look at the configuration of my job. Deploy plugin on test masters. Always the standard Jenkins look and feel. Here you can see that this build is parameterized because I want to upload my Hello World plugin. So I added a parameter of type file parameter so that I can upload the HPI file. And the description is the plugin to deploy. So here I leverage parameterized builds. Then I created an operation based on update center. So I will upload this plugin to an update center. Here on my infrastructure, I created an update center called root update center. You can see it here. We have webinars, we give more details about update centers. So here I select my root update center, and I use the path filter to select it on only this one. And then I have a step on these update centers, just one update center, which is upload plugins. I will cover the various features, various operations available later in the ref card review. Here I use the upload plugin. I select the filter parameter name plugin, the same as the one I defined in the list of parameters of my job. And I will select to promote this version so that this is the active version. So in the past it was version 1.3 that was active, and I will upload version 1.4 and make it, promote it as the latest version. Once I have uploaded the HPI file in the Jenkins update center, I will do an operation on the masters. Here I select the master. First, I select the master called jenkins-test.bishop.org. I still use a pass filter. And I will perform the following steps on this master: refresh update center metadata, and then install plugin. Where do these variables come from? Jenkins plugin ID and Jenkins plugin version. If I look at the upload plugin operation, if I go in advanced, I can see that there are output variables of this upload operation, and the names of these variables are Jenkins plugin ID, so in my case it will be hello world, and Jenkins plugin version, in my case 1.4. So I will install the plugin and then I will perform a safe restart. So this is my configuration. I will run it. Here you can see a parameterized build where I have one parameter named plugin on with the description the plugin to deploy. Oops, sorry. So my plugin is here. Hopefully I can just drag and drop. No, I cannot drag and drop, sorry. There is a small glitch. So this is my Hello World plugin. I select the HPI file. I trigger it. Here there will be various operations. First, I will update the root update center. So here it has been, the plugin has been uploaded to the update center, and then it has been installed on the jenkins-test.bishop.org. If I go, oops, sorry, I have to leave this. Okay, here this is restarting. So I will have to wait a few seconds. While I'll wait, I will summarize for the restart. I will summarize what I have done. So I created a cluster operation job where I introduce a parameter, which is of type file parameter. Then I perform an operation on an update center. So I selected an update center. I selected the update center called my update center or root operation update center in my demo. Then on this update center, I just had one step, which was upload plugin, where I decided to upload the plugin identified by the parameter job parameter plugin. I decided to promote this new version of plugin, and as a result, I had two output variables: Jenkins plugin ID and Jenkins plugin version. This is a way to upload a plugin. Then I performed operations on Jenkins masters. Here I selected my Jenkins master, jenkins-test.bishop.org. I could have other patterns to select the masters. On various steps, various actions on these masters, refresh the update center metadata, and then install the plugin. I identify the plugin by my variables, Jenkins plugins ID and Jenkins plugin version. So this was how I did my update of my plugin. I will refresh the screen. Hopefully, yeah, Jenkins seems to have restarted. I will look at the configuration of my job. And if you remember, before I had the version 1.3 of the Hello World plugin, and now I expect to have the version 1.4. And I promise it's not Ryan who has done the update. And here you can see I have the version 1.4 of the plugin. So this was a demo on how to combine operations on the update centers on the masters to deploy a new version of a plugin. We could also have a demo to not touch the update center, but directly perform the install on each masters. But we recommend to use update centers. Now I will cover another feature of operation centers, of cluster operations. Sorry, these are the quick cluster operations. I will go quickly. When you are in your Jenkins Operation Console, you can easily tick these checkboxes on the right part of the screen, which is OP, where you select Jenkins masters on which you want to perform a cluster operation. So here you then click on cluster operations, and then you can select one of the following operations: prepare for shutdown, reindex for analytics, or self-restart. Let's say that I select self-restart. You have a screen where you see the list of masters that would be modified, impacted by this operation, and you can select run. So this is another style of operations, the quick cluster operations, we could say. Now I will review, to give an overview of what's possible, the operations that are available. When we look at the operations on master, you can trigger a backup, disable a plugin, execute Groovy script, install plugin, prepare master for shutdown, refresh update center metadata, reindex for analytics, self-restart, restart now, upgrade plugins, upgrade all plugins. Then there are operations on the update center. Delete core, so it's a Jenkins core, the WAR file. Delete plugin, promote core to make this version the default version. Pull everything to download the latest version of all the plugins on the upstream update center, probably jenkinci.org update center. Pull new version of the plugins that have already been discovered from the upstream update center. Refresh upstream sources. Track latest core, track latest plugin, upload core, upload plugin. So these were presentation of CloudBees Analytics by Ryan, and then cluster operations by, it was me who presented this. We could see today that there are some key features when we want to scale Jenkins in an organization. We covered CloudBees Analytics on cluster operations. CloudBees Analytics allows you to have a global view of the health of your Jenkins infrastructure. It's valuable both for the operations team who operate Jenkins and for the project teams who want to know the health of their projects. And we covered cluster operations, which will help you to perform maintenance operations on your infrastructure. Sorry. We have more resources on these topics. First, you can find this webinar either on jenkins.com website, where you will find the recording, or you can find the slides that we have presented today on SlideShare. It's a SlideShare account of CloudBees. We also have other webinars. If you want to have a better overview of Jenkins Operations Center by CloudBees, we have a webinar called Building Resilient CI Infrastructure in the Enterprise. We have additional info on CloudBees Jenkins Operations Center. It's available on our website. And that's all for today. So we will then move to the Q&A part. Thank you for joining us today, and have a nice day.